Hello everyone, I am Sham Ratan from second year of Artificial Intelligence and Data Science of Savita Engineering College. I have a project on visual representation of employment skills. In this video, we are going to see about electric cars and how an electric engine works. Come on, let's get into the video. Ever wondered how EVs get from A to B? It is essentially the same as an internal combustion car but wired up to a giant battery, or is there some altogether more tricky afoot? Join us today as we pop the trunk and ask how exactly the electric engine works. Surprisingly, the operating principle behind the most modern electric vehicles predates the internal combustion engine by a number of decades. In 1834, Dutch professor named Serbadan Strangianch Northland has discovered his own small electric vehicle. The catch being its battery was non-rechargeable internal combustion engine works on the principle that fuel and air, when compressed and ignited, cause a tiny explosion. That's the combustion part. This explosive force pushes a piston. That piston's linear motion in concerned with a team of fellow pistons transforms into rotatory motions via a mechanical craftwork. It is turn spins when wheels along the highway. Conversely, the fundamental principle that drives electric cars in magnetism. Everybody knows how opposing poles on a magnet attracts north pole and the south pole. Like poles repel each other, so it's imagine a experiment using two magnets, one fixed to the end, mounted to the nearby rotating shaft. If the two poles nearest to each other the same polarity, say north to north, the magnet of the shaft will be repelled because it is attached to a shaft. The shaft will turn, that is, until the south pole on the shaft magnet is aligned with the north pole on the fixed magnet, where the shaft will again be still. In our imaginary experiment, we have made the shaft turn a half rotation very well, but that won't get us very far on the morning compute. Here's where electromagnetism enters the chat in a fixed or permanent magnet, like the kind you have on your fridge at home. Those magnet poles are rigid and never change. North is always north, south is always south on the electromagnet, however, which is essentially a core of metal coiled in an electrical wire. This magnetic polarity can be reversed. Imagine one of our experimental magnets is now on electromagnet. If the south pole quickly repels, the fixed magnet will yet again repel the moving magnet. Rotating shaft another half spin. That's a whole spin. Now we are slowly getting there. Therefore, a basic illustration of how this is polarity reversal works. Imagine a very simple circuit involving a battery and a light. Electrons are revolving one direction from the battery through the wire to the light bulb and back again to the battery. If we remove our battery from the circuit at 180 degree, then replace it in the circuit, those electrons will still flow around the circuit, just a opposite direction either way. Bulb lights up. Electromagnets, like light bulbs, work whichever the direction the electrons are flowing, but rather brilliantly the polarity of the magnet get reversed with the flow of electrons. So to keep our magnets in a permanent repel mode, we just need to keep reversing the polarity of the magnet. How do we that? One way could be to keep popping out the battery and flipping it around, but that's a lot of strips to the mechanics with the EV for the sake of new feet covered. So that the real trick to making a magnet spin, which is essentially how electric motor work, is through called inventor. The inventor module of the EV draws direct current from the car battery, and though a clear combination of quick switches click circuitry and capacitors. Flip the flow of electrons back forth nearly 60 times a second. Domestic electric motors like the one you have your hair dryer do not require any inventor. Why? Because the current that comes from a wall outlet already flips back and forth. That's why it is named as alternating current. The AC batteries of any type can only ever produce DC or direct current, so spinning magnets driven. The alternating current passing through coils of the wires is essentially what drives electric cars. Electric power trains have a number of advantages over the internal combustion engine. For starters, the motion produced by the motor is already rotatory in nature. Dirty pistons on a ice require a complicated breakable crankshaft just in order to linear motion into a rotatory movement. So, EV cars are less likely to fail or require expensive time consuming maintenance years. Another clever thing about the inventor, by adjusting the frequency and amplitude of its newly created AC current, like the vehicle speed and torque, can be finally calibrated by the driver. There's no such fire control but built into an explosive hot internal combustion engine, which is why expensive. And accident prone additions like gearbox or try some necessity. Another nifty detail about any EV's powertrain is when the shaft mounted magnet or rotor in engineering is itself spun. It generates electricity. This reversal very handling recharges the car battery. How can the rotor be turned, you ask, with a hefty source of kinetic energy like, say, a braking automobile? One particular California car company, named for the 19th century genius who discovered the magic of alternating current, by himself, Nikola Tesla. Therefore, the time is right for electric cars. In fact, the time is critical. Thank you.